So we've done linear inequalities in one variable. We're now going to do quadratic inequalities in one variable. So quadratic inequalities in one variable. So I'm going to assume I've moved everything over to one side of the equation, and what I'll be looking at is just anything of the form ax squared plus bx plus c, and of course I could have less than or equal to 0, or I could have anything else. So I could have bigger than or bigger than or equal to, etc. Probably the easiest way to solve things like this is just, first of all, to solve the quadratic as you would normally, and then draw it graphically. And then you can spot from there what's going to happen. So, first of all, solve the quadratic y equals ax squared plus bx plus c. I've written it as y because I'm going to set that equal to 0. Now, of course, it may not have any solutions. If b squared minus 4ac is less than 0, then there are no solutions. And if that's the case, then you know what it's going to look like. So it either looks like, so it doesn't ever hit the x-axis. So it either looks like this, and that's if a is bigger than 0. So what am I plotting here? I'm just plotting y equals ax squared plus bx plus c. So that's if a is bigger than 0. And otherwise, it's going to look like this if a is less than 0. And depending on what you're solving, then you'll either have infinitely many solutions or you'll have none. So if we are solving a x squared plus bx plus c is less than or equal to 0, and a is bigger than 0, then it's this curve, but that is never less than or equal to 0. So no solutions. On the other hand, if you take ax squared plus bx plus c and a less than 0, then this always works. So this value is always less than 0. So if ax squared plus bx plus c is less than or equal to 0 and a is less than 0, the solution set is just anything, so x in the reals. Okay, so that's one particular case, is where the quadratic has no solutions. The quadratic equation has no solutions, but then you get either no solutions or infinitely many. The other case is where you do get solutions. Otherwise, we could have, well, let's just take the case where b squared minus 4ac is strictly bigger than 0. And then you get, and if you think of the quadratic equation, you know that this is what comes under the square bracket. So you get two different ones if this is bigger than 0. So we either get something like this if a is bigger than 0, or we get something like this if a is less than 0. Now, I'm just going to focus on this case here, and then we'll look at the two possible ways of being interested in the solution. So if y is equal to ax squared plus bx plus c, and a bigger than 0, so we look like this. Let's suppose we want ax squared plus bx plus c less than or equal to 0. And let's suppose I've found that the two intercepts are r and s. Then I know where is this less than or equal to 0, just between these two values. So less than or equal to 0, that's if and only if x is in the bits between r and s. So that's minus r to s. And because it's less than or equal to 0, I do include the two endpoints. If I had ax squared plus bx plus c strictly less than 0, then I would take x in my, sorry, we haven't said that r is negative here. Could be or not. And we say x is in rs, not including the endpoints. And then there's one more. It's worth saying what happens if we're bigger than 0. I won't do bigger than or equal to, but if ax squared plus bx plus c is bigger than 0, when does that happen? Well, it happens either when you've got x bigger than s, or you've got x less than r. So that happens when x is in s to infinity union minus infinity to r. And you get similar things, expressions for a less than 0, which I won't do, but let's also just take one more case, which is, I'll do with an example. Let's suppose we wanted ax squared, so we'll take, we'll solve x squared minus 2x plus 1 is less than or equal to 0. So we've all seen this quadratic before, and we can solve it by plugging it into the formula, or we can factorize it. I'll choose to factorize it. So this is true if and only if x minus 1 all squared is less than or equal to 0. And then we know how to sketch this quadratic. So y equals x minus 1 all squared is going to look like that. It has exactly one solution just there. And in that case, I get a single solution. So when is this less than or equal to 0? Well, it's only less than or equal to 0 in exactly this one place where it actually is 0. So we get one solution, x equals 1. Okay. So one more thing I want to say about this, and that's you don't have to do this graphically. So can also solve from the factorization. So if you've got, let's say we took x minus 2, x plus 1, less than or equal to 0, then just have a think about when these two are going to be positive or negative. So if we want to get a negative number, we have to multiply a positive one by a negative one. So if I take x bigger than 2, then both of these are going to be positive. so I don't want that. And similarly, if I take x less than minus 1, then they're both going to be negative, and I don't want that. So it has to be between the two values. So this is negative. Well, this is positive when x is bigger than or equal to minus 1, whereas this is negative when x is less than or equal to 2. So if I'm between these two values, I've got one of them positive and one of them negative. So minus 1 is less than or equal to x less than or equal to 2, or I could just put x in minus 1 to 2. And similarly, you can solve it using the completing the square. You end up with a very similar expression. So those are two ways to solve it, but can also solve by completing the square, and you can see the lecture notes if you want to do it that way. But probably the graphical one is the one that is less likely to go wrong. Okay.